Dear students, see, this is today's class test questions. So now the answers. So remember, actually the paper is you are feeling very difficult, but the paper is very easy because you are not confident about all the formulas as well as the principles behind this gravitation. Okay, that is only the reason. No worries. On practice, you will get that confidence. Now look at the first problem. Energy required to move a body of mass m from an orbit of radius 2r to 3r they given. So now what is that is work done? Now the energy change, how much change your energy is increasing to move from this first orbit to the second orbit, where the radius of the orbits are 2r and 3r respectively. Now take the total energy. Total energy total energy, the first one is minus gmm by 2r, and total energy final when you are moved to 3r distance. 3r means in the sense the orbit radius is 3r, then minus gmm by 3r. Now the difference indirectly, the difference gives your work done. And that work done is nothing but the energy, how much it is needed. That is equal to gmm by r by 1 by into 1 by 6. Option D is correct. Now come to the second one. Second one is directly the second law of areas. Conservation of angular momentum, dA by dt. Already aerial velocity we proved. Aerial velocity L by 2m. Here 2m is constant, only L is the variable, or depending on what factors, that is mvr. So in mvr mm gets cancelled. Again only what is there, variables velocity versus we're getting the radius. Okay, radius of the circular orbit. Now v in terms of angular velocity, just here there is no linear speed is not given. So now you can convert that velocity into angular velocity. Angular velocity and linear velocity relation we know, that is v equal to r cross omega. So now from this you can substitute v equal to r omega, you will get omega r square. Fine, option C. Now come to the third bit. What the third bit is clearly mentioning. A mass of 6 into 10 power 24 kg. Remember, this is basically the sun mass. Okay, is to be compressed in sphere in such a way that the escape velocity from the sphere is 3 into 10 power 8 meter per second. If any particle is given this much huge velocity, then only it can come out. Otherwise no particle can escape from that atmosphere. Okay, now radius of sphere should be how much it is. Simply escape velocity formula, escape velocity root 2 gm by r. Now that you need but r, now you need to bring out outside. So now squaring on both sides, you will get r is equal to 2 gm by va square. Now all the values substitute, all 2 into g value 6.67 they given, they provided already. Now substitute that and mass by velocity square, velocity of light square, 9 into 10 power 16. If you simplify this, you will get how much? 9 mm. What it means that the sun size, already how much huge size it is that. Now the radius of that one is 9 mm, means this much size only. Exactly what the figure is drawn here, this much size. If you bring that's such a huge size. This is the body where the condition is commonly called black hole. Now if you can able to compress such a huge mass into small size, now it will act like a black hole. It can attract every mass into that. Okay, now come to the fourth question. If a new planet is discovered rotating around sun with the orbital radius double that of the earth, then what will be its time period? Commonly that's the basic formula, we know that. Yes or no? The square of the time period directly proportional to cube of the radius, we know that. Yes or no? So by using that, t1 by t2 equal to a1 by a2, t1 by t2 is equal to a1 by a2 whole power 3 by 2. Now use that formula, just substitute whatever double the radius they given. Okay, initially the period of earth is time period is almost 365 days. Yes sir, 365 days. Now these are also non values double, so now they will get seconds. 1 by 2 will be there, so 1 by 2 whole power 3 by 2 is nothing but 1 by root 8. 1 by root 8. Now substitute that. Now you need the time period of this planet. Yes or no, the planet which is having double the radius. Yes or no, double the orbital radius of the earth. Now T2 is equal to root 8 times T1. Now root 8 is nothing but what, you know that you can write like 4 into 2. Now 2 root 2 is the value. Now 2 root 2 into 365 days. If you multiply, you will get 1032 days. Okay, roughly. Okay, rough value. Now come to the fifth question. Fifth question is very easy. So now the third law of periods. Yes sir. Now what the law of periods is directly proportional to r cube means, in the sense that is equal to some proportionality constant is there. Now directly the given t square and r cube, that is in along x axis, y axis and x axis. Now take the slope of this, you will get a constant. Yes sir. Constant, you must you need to know when the time is 0, indirectly that r is also 0, though this must passes through the origin. This must passes through origin. Maybe you can get this also, but this is not passing it. So it means if r is 0, even r is 0, some time period is there, means that is wrong. Okay, that is wrong. Next, question number 6. Question number 6 is gravitational field intensity related graph they given. As an for a spherical shell, commonly spherical shell. If the spherical shell, if you take, suppose, so this is a spherical shell. Derivations also. Okay, derivations once go through the notes or the textbook, you can get. Okay, now that is the reason inside the field intensity is 0, but on the surface it is maximum. It is maximum. So now from that again inversely proportional to r. Inversely proportional to r it will go. Now field intensity means r square only. Inversely r square. Inversely proportional to r square. So now indirectly the graph is looks like the fourth one. Yes, and why this is 0? So suddenly maximum at where the r is equal to the radius of that. So now beyond that again it is inversely proportional to r square. It is decreasing. Understood? Now that is the question. Next one is seventh one. Seventh one is you need to know how the g value changes. Suppose they given a mass. Two planets are there. One is Earth, they given, another one is Mars. Okay, on Mars acceleration due to gravity they given 4 meter per second square. On Earth it is 10 meters per second square. Now if 60 kg passenger, what is his weight basically on Earth? That is 600 newtons, because mass into g is the weight. Okay, now 600 newtons. Suppose the same person is reached, let us suppose after reaching, what is his weight? So his weight is almost 240 newtons. 60 into 4, 240 newtons. Now fine. But while he is moving from Earth to Mars, what is happening basically? Initially he started at an acceleration due to gravity 10. Slowly when the height increases, g value decreases. G value decreases means weight must be decreases up to where it will be decreased. So we know already the neutral point somewhere we found in between two massive bodies, always the gravitational field is 0. When we reach that point, the total weight is 0. In which case in this graphs you will get 0. Only this is the case. Case C, it will reach us to 0, and again when you are reaching and the height is decreases, so your the acceleration due to gravity increases up to 4 meter per second square. So that is the reason the curve G is the correct option for this. Okay, finally it reaches a weight of how much? 240 newtons. Okay, during the total journey. Next, eighth question number 8. Again this is, so basically this is a procedure for anything. We know what is the time period proportional to cube of the radius. But already we discussed, if these are geosynchronous satellites at around 36,000 kilometers height, but we learned what is the low Earth orbits low earth orbits also we are having, where we studied this is in polar satellites. During polar satellites, the time period is already we discussed, it is around 100 minutes. 100 minutes is nearly equal to how much more? 2 hours. Yes or no? 2 hours. So that is the reason. If you go through this calculation also, take the radius, yes or no, very close to earth, no, they given hundreds of kilometers above. If you can increase this one also up to maybe 300, maximum 800, I said we discussed, yes or no, 500 to 800 kilometers radius for low earth orbit satellites, yes or no, satellites. So that is the reason you can enhance this value up to maybe 36,000 by around you can take 6,800 or 900 or 7,000 you can take on an average. Okay, you can take 7,000. So roughly you will get what, not 2 hours, you will never get 2 hours basically. Okay, that is the nearly, they clearly mentioned approximately. Okay, that is the reason, 2 hours. So now without doing problem also you can choose, this is around 2 hours. Why? Because 1 hour is far away from this 100 minutes, and half hour is also, this is 4 hours also. So now you can easily choose this by a common knowledge. Okay, now come to the problem number 9. Problem number 9 is again it is from earth's surface or into the, when you from the center, when you are moving, suppose if you take an earth, yes or no, from the earth you are moving either going downward, yes or no, depth, or going upward from the altitude, yes or no, altitude. So g value increases or decreases indirectly, yes or no, acceleration due to gravity. So when the height increases, that will be decreases g. Why? The g is always inversely proportional to r square. Remember here the distance, height square, yes or no. So now certainly it will decreases, the height increases. So similarly when the depth when your depth is increases, so now that will be leads to minus value, indirectly decreasing. Already we discussed this. Okay, now remember why you need not to choose this also. Here both are straight lines, here both are not straight lines. The reason is, the first one, when the height is increases, remember this is very important point. Why? Because as this is a function of inversely proportional some x square, yes or no, some constant by x square, means that second order function is always like a curve you will get, you will never get a straight line. So now the first order, in first order is the power must be always 1. So here this is looks like a straight line, already we discussed, y equal to some constant into minus that negative slope, and directly what it is going, already we discussed. Now this is, you can write like this, g minus g, of course surface, on surface, into this is d by r. Here these two are constant, only variable is the depth. So now you can write this is some intercept into minus, this is some other constant into some variable, yes sir. You can write like this, y equal to some, this is a slope, you can say slope. So now negative slope, indirectly when you are going downward, not going upward means that is different, going downward means that is different. Okay, that negative symbolizes decrease in value. Okay, that is the reason. So this will be straight line. Okay, inside this is a straight line when you are comparing the outside. Why? Because this is minus slope into some x r, yes or no. This one will be again decreases as the height increases, but inversely proportional to some x square, the distance square indirectly as the height increases. Okay, now go to the problem number 7. Similar, already previously we discussed, this is repeated question, I thought, yes sir, previously repeated or not somewhere. Yes, here see. So both question number 6 and 10 both are same, repeated. Sorry for that. Now question number 11. So this is already a formula, derived formula. Already we derived that formula is, suppose a projectile is projected, okay, with a velocity k times escape velocity in vertically upward direction from the ground into the space. Okay, v is the escape velocity, everything is we know that. Yes sir. Now suppose, remember, we know this is, if suppose this is a fractional velocity, the projected velocity is a fractional velocity of this 1 by n. Now we got this relation, h equal to the height reached by that projectile is equal to r by n square minus 1, n square minus 1. But suppose if you take k times v, k times v, k is also another an integer, maybe it is a fractional number, we don't know about that, exactly. Maybe any number, maybe it will add it. Now when you come to in place of 1 by n, k is there. What it means? 1 by n is equal to k. Now from this n equal to 1 by k. Now just substitute in place of n 1 by k, you will get a relation. You will get a relation. Now I will derive this. You should check here. See, now if I substitute here, this is equal to 1 by what? 1 by k square minus 1 you will get. Yes or no? Now this is equal to r by 1 minus k square by k square. That k square I can write here. Yes or no? K square I can write. But this is the height reached. But they are clearly mentioned here. Remember, once again read. Is height, maximum height reached from the center of the earth. Okay, center of the earth to which it can go. So center of the earth means you need to add for height h. Actually this height formula we derived from the surface. From the surface. So now you need to add r for this. Now the total height reached from the center is indirectly h plus r. H already you calculated, r k square by 1 minus k square plus r square. Now if you solve this, you will get r by 1 minus k square. 1 minus k square. Remember that. Okay. Sorry, this is r, no? Sorry for this. R. Okay. That is the reason. Okay. Don't confuse here. Okay. Now come to this again. This 12th problem. The diagram shows that variation of gravitational potential of Earth with the distance from the center of Earth is. From the center of Earth is. See, we derived this relation in the classroom. Okay, in the classroom. Okay, look at problem number 12. The diagram showing the variation of gravitational potential of Earth with the distance from the center of the Earth. Okay, from the center of the Earth. See, the potential formula on the surface we know, that is equal to V minus Gm by R. Sir, Gm by R. Even outside also, but if it is greater than that, if R is greater than the radius of the Earth, then for that also you are getting the same formula, but minus Gm by R. But when you, if you take, when you are entering into the Earth, when you are entering into the Earth, remember the potential is slowly increases inside. The potential is slowly increases. So the maximum potential, why? Because potential is a scalar, remember. Okay, potential is a scalar. When you are going inside, you need to add up all these bodies. Even the distance is decreases. So thereby maximum it is increases, but in the sense negative only, remember that. Okay, binding energy only. Inside, how as the distance r increases, yes or no? R increases from the center, or r decreases from the top to the bottom to the center. So now minus Gm 3r square minus r square by 2r cube. 2r cube. Now this is the relation. This is the relation for r must be less than r only. Okay. At center, if you need, at center, just substitute small r value is 0. Now you will get minus 3 by 2 gm by r. When you are comparing with the surface, that is 3 by 2 means 1.5 times, so on the surface potential. So now it is greater. So that is the reason it is slowly decreases as you are coming out from the center. Okay, center and beyond it will follow as usual. If r is greater than r, so that will follow general formula gm by r. So on the surface just minus gm by capital R, but inside only it is different for earth, means the solid sphere of mass of radius r. Remember, this is sometimes very important. Okay, but these are for board, it is not there, for competitive exams, purpose of the competitive exams only. Next, problem number 13. See here, an artificial satellite moving in a circular orbit around the earth has a total kinetic energy plus potential energy together. Okay, total energy they given E naught. Its potential energy is, you know the relation between potential energy and kinetic energy, yes or no, the ratio of this. But think here, this is, don't take the negative signs. If you take negative signs, the total problem will be wrong. Okay, but actually they given just magnitude only they given. So if it is E naught, what is the potential energy? Potential energy is simply 2 E naught. Both are negative only already. If it is binding, so both are negative gets cancelled. Simply their ratio is 1:2. That's all. 1:2 that. So that is the reason 2 E naught. Okay, 2 E naught. Next, problem number 14. So they given, if the radius of the earth were to shrink by 1%, okay, its mass remains same, acceleration due to gravity on the earth's surface would be, see, g formula is gm by r square. So now here g is constant, capital G. Mass of the body solar system is also constant. Only the problem is radius is changing, slowly decreasing, 1%. If it is 1% decreasing, what g will be affected? How the g will be affected? Now look at this formula. Already in the first chapter we studied the percentage of errors. Okay, so similar here, if the percentage change in gravity, if you need, that is equal to the power here. Remember, either it is inversely proportional or directly proportional. You need to add up only. The variation must be always add up. So that is the reason 2 times the percentage change in the radius. Okay, the percentage change in radius. Now that is they given percentage change in radius is 1%. Now 2 times 1% equal to 2%. That is increases or decreases. G value will be increases. Remember that. Why? Because inversely proportional. So G value must increases. If it is decreases, means the numerator is remains constant, denominator is decreases, certainly G will be increases. That is important. Next, if orbital velocity of planet is given by v equal to g, capital G means their respective significance. Remember that this is mass, this is radius, this is universal gravitational constant. Now you know this is just how you can solve all the the powers. Just add up the powers. Okay, then you can get the problems are solved. Okay, see, this is m power, not L. Why? Because velocity L t power minus 1. So now this is commonly, otherwise this is, look at here. Sorry, I will take this. So this is, what is the unit of G? We know Newton meter square per kg square. So that is converted into basic dimensions. What is ml t power minus 2 mass into acceleration into, this is into my L square by m square. Okay, meter square they given. So Newton meter square means L square by kg square. Now that is Now m here mass only, directly you can take this is mass power b. Next radius is the length power c. Fine. Now you know, just distribute this one and bring it and resolve and write down how many m's are there. m power b, this is minus a. So next, this is how many l's are there, l cube power a plus c. Next, t power, how many, t power minus 2a, one left there. Okay, right. Now when you compare this both LHS side and RHS side, what are the things are there? See, m power b minus a, that is equal to 0. What it mean indirectly? B equal to a, b equal to a. Now l power 3a plus c, so that is equal to l power 1. So now we will get c is equal to minus of. Now substitute here the just already they given a value, b value, c value they ask. So now indirectly these are the dimensions. Yes sir, these are the dimensions. So with respect to g, m and r. Now that is of and minus of. Next, problem number 16. So the distance of Neptune and Saturn from Sun are nearly 10 power 13 and 10 power 12 meters respectively. Assuming that they move in circular orbits, their periodic times will be in the ratio. We know again the same formula, law of periods, T Neptune by T Saturn is equal to R Neptune by R Saturn whole power 3 by 2. Okay, but they given this ratio Rn by Rs is equal to 10 power 13 by 12, 10. Now substitute that one, you will get 10 cubic 1000 under root, how much it is? 10 root 10, 10 root 10. So that is the ratio of the time periods. That is the ratio of the time periods. Now come to here, this is the 17th problem. The orbital angular momentum of satellite revolving at a distance r from the center is L. Okay, if the distance is increased to 16 times of the initial one, the new angular momentum will be the new. See here, this is m, v naught value we know, gr, orbital velocity into r. Okay, keep it, that is the initial one. Now the final after changing, yes, mass is remains constant, only the change is r. Yes or no? G, r will become 16 times initial. Yes or no? Initial r. Now this is again, this r is 16 times initial. Okay, outside also. Now if you place this, so simplify, m is there in 16 4 you can bring it out, this 16 is there, together 64 4 16 is 64. Now what are the things are left there? Root g are there under root, and outside r is also there. Now this is almost this one only, no? Initial angular momentum. Now that is 64 times initial angular momentum, final angular momentum is. Okay, down this. Next, problem number 18. So this is also about again the conservation of momentum only, angular momentum. That what it means. Now see, at the maximum and minimum distance of a comet from the sun, 8 into 10 power 12 meters and 1.6 into 10 power 12 meters. If its velocity when nearest to the sun 60 meters per second, nearest to the sun velocity is more. When it is farthest means, so the velocity certainly decreases. Why? The area velocity must be remains constant. So that is the reason. So either this, answer this. You need to eliminate like that first initial in the first point when you look at. So now after that you can check. Now here, sorry, m1 v1 r1 m2, of course m1 m2 are both are same here. So v2 and r2. Now m1 m2 are same here, the same body, they are same comet as r. So now it will be gets cancelled. This is r2. So now substitute their respective values. See here 1.6 into 10 power 12. At that point its velocity is 60 meter per second. Then that is equal to 8 into 10 power 12 into v2. Now that v2 is, you will get, if you solve this, you get cancelled. Finally you are left with 12 meter per second. Now 19th problem. Let's look at the line 19th problem. Two planets at mean distance d1 and d2 from the sun and their frequencies are n1 and n2 respectively. Then remember, already we have this relation time of periods. From here you need to know what is the relation between frequency and time period. Indirectly 1 by time period is nothing but the frequency, cycles per second. So the from this, in the place of 1 by t1, 1 by t2, n2 you can place 1 by t1, you can place n1. So now inversely proportional, so these two are, so now that is the reason in the place of t1 by t2 I can say n2 by n1. So n2 by n1 whole square is equal to d1 by d2 whole cube. Now cross multiply, you will get this relation. Yes, sir, relation. Next, problem number 20. A satellite which is geostationary in a particular orbit is taken to another orbit. Okay, its distance from the center of Earth in a new orbit is 2 times that of the earlier orbit. Okay, the time period in the second orbit is again the same formula. Okay, t1 by t2 equal to a1 by a2 whole power 3 by 2. Okay, if you substitute, you will get, see here, 24 is the time period. Yes, time period of in hours. Yes, no, commonly that what for what that is geostationary satellite time period we know. Now let us suppose t is the when its radius is doubled. Okay, then time period let us suppose t. So then from this radius only the time period is unknown, the remaining all are there available. Now simplify this, you will get 24 root 8. So now that is equal to this root 8 means you know that is 2 root 2. Now again that is 24 times 2 is nothing but 48 root 2. Okay, 48 root 2 hours. That is the time period. Now problem number 21. See here, a satellite with kinetic energy Ek is revolving around the Earth in a circular orbit. How much more kinetic energy should be given to it so that it must escape into outer space? It can escape into. So now in a satellite is revolving in with a kinetic energy means that is orbital kinetic energy only. We need to remember that. So now it needs the escape velocity. So now if you can give half mv square, that is equal to orbital velocity plus some additional velocity. So now if both when you are given this additional extra kinetic energy for this, already it is having this much kinetic energy, certainly that will escape. So now simplify this, wherever v is there, v in terms of orbital velocity 2v0 whole square root 2 v0 whole square. So now 2v0 square, that is equal to half mv0 square. Simply say this is some kinetic energy. Yes or no? Kinetic energy, what the additional kinetic energy needed. Okay. So now if its name is kinetic energy needed, now that is equal to send this one other side. This is 2 times of this. Now we will get half mv0 square. How much already in the orbit it has? The same amount of energy it needed. See the problem number 22. The escape velocity for the Earth is 11.2 km per second. The mass of another planet is 100 times that of the Earth, and its radius is 4 times that of the Earth. The escape velocity for this planet will be. So now remember the general formula, V equal to root 2gm by r, that is equal to 11.2 kilometers they given. Suppose if the mass and radius varies, what will happen? Suppose for the another planet 100 times its initial mass of the first planet or the Earth they given clearly. Now when you are comparing the planet's radius with the Earth radius, that is 4. Now from this simply you can get this 104 as 10 by 2 out of the root. Now the remaining thing is nothing but again what is this, 11.2 kilometers per second. Now this is 2 5s. Now 5 times 11.2, that is equal to 56 kilometers per second. What it means directly, if suppose such a planet existed 100 times the mass of the earth, as well as the radius must be 4 times the radius of the earth. So then any body can escape from this if you provided 56 kilometers per second. Such a huge velocity it needed to escape. Understood? Next, problem number 23. The depth d at which the value of acceleration due to gravity becomes 1 by n times the value at surface is So clearly they mention. So at a depth, what depth? We know the formula. At a depth d is equal to g on surface 1 minus d by r. So in the place of depth you place here g by n. Now g gets cancelled. So 1 by n is equal to 1 minus d by r. Now you can separate d. That is r into n minus 1 by n. When you are looking immediately, you can feel there is some difference. Just read first completely the problem. Okay, automatically you can get some idea. Now look at problem number 24. Assuming to be a sphere of uniform density, what is the value of gravitational acceleration in a mine 100 kilometers below the Earth's surface? Given radius is 6400 kilometers. Okay, assuming Earth to be a sphere of uniform density. Okay, density is not varying, what they are saying. Why? Because sometimes density can also change g value. So now gd, we know already the formula. At a depth g varies by using this formula, 1 minus d by r. Substitute the respective values. Here g is 9.8. So now when you substitute this, 63 by 364, this much fractional of the surface acceleration due to gravity will exist. If you simplify, you will get that is 9.66. Now problem number 25. The kinetic energy needed to project a body of mass m from the Earth's surface to infinity. That is indirectly whenever this kinetic energy equal to the potential energy on the surface. Potential energy on the surface we know that is mgr. Of course that is in the minus sign. Okay. Now otherwise solve normal problem. Half mv square, escape velocity is equal to half m. Now escape velocity formula root 2gr. So now if you simplify that, you will get mgr. Fine. Next, problem number 26. So this is simple logic. Field is a vector. So now at center 3 masses we are placing on an equilateral triangle. Now all are attracting with equal intensity here. So what it means, the net field is always zero. So next, if it is potential, that is different. If it is potential, that is entirely. Potential is a scalar, it will never get cancelled by the direction. Now take 27. The ratio of the radio of planets A and B is k1 and ratio of acceleration due to gravity on them is k2. The ratio of escape velocities from them will be. See, ratio they given r1 by r2 they given k1, g1 by g2 they given k. Now escape velocities root 2g1 r1 by root 2g2 r2. Now 2 gets cancelled. So r1 by r2 left there under root and g1 by g2 left there. So now substitute their respective values k1 and k2. You will get root k1 into k2. Next, problem number 28. Many solve I saw, but they chosen this one. Potential energy is always negative. If they didn't mention this and this option is not there, let us suppose, then you can choose this. But this option is there means you need to use this one. Why? Potential energy is always negative. So that is the reason. Okay, half mv square, the same formula only. Potential energy equal to minus of mve square. Okay, escape velocity square. Okay, now in the given all everything, just substitute, you will get 5000 joules, but negative. You get 20. Problem number 29. This is related to the gravitational field relation with the gravitational potential. So this is gradient, negative gradient of potential. Why? Because this is a conservative field and conservative forces. Yes, sir. So now if you apply integral both sides, you will get, and just in the place of field you can put k by x cube. Then after integration, what you will get? V equal to minus k x power minus 3 plus 1 by minus 3 plus 1. So now this is x power minus 2 by minus 2. So now 2 will come out, and then apply the limits. You will get k by 2x cube. Why it will become plus? Means already in the formula it is there minus, and again after operation of integral, you are getting one more minus here. Minus gets cancelled, remains. So now k by 2x cube x square only left there. Okay, left there. Problem number 30. A body of mass m rises to a height h equal to r by 5 from the earth's surface, where r is the earth's radius. If g is acceleration due to gravity at earth's surface, the increase in potential energy is just calculate what is the potential energy here and what is the point. It is a comparatively huge value. Now compulsory g value will change. Yes or no? Now at a height you can use more precise value you can get when you are taking a direct formula. Don't take approximation formula. At a height 1 plus height by r whole square. Okay, this is the formula for calculation of acceleration due to gravity at a height h. Now you will get 25 by 36 g. Okay, now at this point mgh again. Now substitute, that is how much the distance r height is from the center. Always you can take r plus r by 5, that is 6 by 5 r, and g values here is 25 by 36 into g and mass. Now the potential difference they are asking, remember that potential energy difference. Now this potential energy minus this, or this minus this, you can take, you will get finally 5 by 6 mgh. Okay, 5 by, see, many done very less marks you got, many got around 8 to 10 marks, this range many. So the remaining 20 problems are there. Please solve all the problems in the notes, all these problems. Okay, so very tomorrow I will check all these problems with concept. If I will ask to solve on the board, means everyone must able to do these problems. Okay, good luck.